Hello friends, today we will see the next topic from the ITCCN subject is error corrective codes. The classification of error corrective codes. In last lecture we have discussed about how which are the techniques of error corrective codes. Now after that there is a classification of the error corrective codes. In the error corrective codes on the basis of parameters. Okay, on the basis of parameter, we are having basically two types of the error correcting code. First one, it is a linear code. First type, it is a linear code, and the second type, it is a non-linear code. Non-linear code. Okay, in the non-linear code and linear code. Okay, linear code. When we say that particular code is nothing but a linear code. See, we are having a very much important property regarding the linear code is that when the sum of two linear codes that should be valid code words, the addition of two valid linear code words will generate a new valid code word. This is the most important property of the linear code. Okay, then and then only we say that particular code, new generated code is nothing but a linear code. Okay, and the difference between non-linear code and linear code as this property, the addition of these two new code words is not satisfied with the non-linear code word. Remember one thing, when we apply all the code words in practically, that means when we use the practical codes, all these are the linear codes. Okay? All which we have used the linear codes or the practically used codes, these are nothing but only linear codes. Okay? Not a non-linear code. Now see the properties of the linear code. These are the different properties of the linear code. To verify the linear code, all these properties must be satisfied. Then only we say that is the code which belongs to the linear code. Okay? See that in that first, the sum of two valid code words. Sum, it is nothing but a addition. Addition in the modulo 2 operation. The sum of two valid code words is nothing but a new valid code word. Okay? This is the most important property of the linear code word. Then second property, the code word element are when we consider that we are having a code word, but the elements of that code word are equals to 0, that time the new generated code word, it is nothing but a, this is also valid code and it is called as the all zero code word. Okay, and this is also a valid code word. Valid code word. Then third property is that the minimum having distance. In between the two code words, the minimum having distance is equals to the minimum weight of two non-zero code words. Minimum weight of two non-zero code words. Okay. See, the minimum having distance between the two valid code words is equal to the minimum weight of two non-zero code words. When this property also satisfied, at that time we say that code is a linear. And the last, the difference between any two code words. Difference between any two valid code words is a new valid code word. Okay? This property is the same as the first one. There is a addition is there, sum is there, and here it is a difference. When we are having a two code words, this is the code word and this is the second code word. When there will be a difference between 1 minus 2, at that time whatever the difference generated from this operation is nothing but a new valid code word. Okay, when we satisfy all these four properties, then we say that this is the linear code word. Okay, and that is not happening with the non-linear code words. That is regarding the classification of the error correcting code. In the error correcting code, we are having on the basis of the parameters two types, linear and the non-linear code. Now, see the another parameter of the classification of the error correcting codes. Error correcting code. There is a classification based on the functioning. Classification based on functioning. Classification based on functioning. On the basis of function, we are having error correcting codes. Error correcting codes. The two types. Block codes and the convolutional codes. Convolutional codes. Okay. On the basis of functioning, we are having two types, block codes and the convolutional codes. See the difference between these two codes, block codes and the convolution code. In block code, there is no need of memory. No need of memory. And in convolution code, there is a do need memory. Do need memory. Okay, these are the two types of the block codes and the convolution codes. Now we will see the details about the block codes. Okay, just remember here one thing, as block codes there is a no need of memory, and in convolution code do need memory. Okay, from this block codes and the convolution code, we will see the details about the block codes. Block code. Okay. Now we will see how we generate the block code from the original message. We are having a block code of we require channel encoder, and from this channel encoder we are having a message base. Message base. And the generated code words. The generated code words after the channel encoding, we are having a new form of the code word. It is called as K message bits. K message bits. And here n minus k parity bits. N minus k parity bits. Okay, and this is the length of n bits. This is the new code word. Okay, and it is code word generation of n bit block code. Generation of n bit block code. Block code. See what will happen in the block code. Okay, we are having the channel encoder. Okay, before that, whatever the message bits which we want to transmit, these message bits, these data which is given to the channel encoder. The function of the channel encoder is whatever the given message is nothing but a k message bits. Along with they have added the some parity bits. This is the function of the encoder. That is the encoding of the number of bits which is comes from the source, and that is nothing but this channel encoder which gives the new code words in this block format. That's why it is called as the block code. What is this block format? We are having a block of n bits. We are having a block of n bits. In this n bits, we are having k message bits. Whatever the message bits coming from the source are nothing but k message bits. Okay, and these k message bits are added with the n minus k parity bits. N minus k parity bits. That is nothing but here whatever the added parity bits are nothing but the value of n minus k, because our total length it is of n, and the k message bits are minus from the total n minus k. That's why whatever the parity bits are nothing but the value remaining n minus k, it is nothing but parity bits. These parity bits are added by the encoder, and these parity bits are nothing but a redundant bit. Redundant bits. Because in this redundant bit or the parity bit there is no any information. Okay? That's why these are called as the redundant bits. This is the generation of n bit block codes. Why it is called as the block codes? Because in this whatever the given message is there, that will be added with the redundant bit or the parity bits. That's why they form a block of n bits having k message bits and the n minus k parity bits of the redundant bits. And remember one thing regarding this block code, there is no need of memory. No need of memory. Okay? That is the block codes. Okay? Yes, understood? Now we will see the next type of the error correcting codes, that is called as the convolutional code. What is convolutional code? Convolutional code. This is the second type. Convolutional code or the convolutional code. In the convolutional code, we are having a diagram with encoder with impulse response absorbed state. Encoder with impulse response let of t. Okay. This is, and from this we are having the input of message m of t. Message m of t. And the output, it is nothing but a convolutional code. Encoded output encoded output is nothing but m of t into h of t. This is the encoded output, and this is called as the convolutional code. Name of the node is the convolutional code. Convolutional code. Okay? What will happen in the convolutional code? Okay? How convolutional code can be? Okay, here. How convolutional codes can be generated? See what will happen in the encoder with impulse response adopted. Whatever the message bits m of t is there, these are nothing but discrete time convolution of input sequence. These messages should be in the discrete nature. They should be in the discrete nature, and this is called discrete time convolution of input sequence. Whatever the are all in the discrete input sequence with impulse response of the encoder, and these sequence of the discrete signals are given to the encoder with impulse response, and there should be a with the impulse response, the generation of the encoded output, we need a memory for the generation of the impulse response. Here we need memory because this memory, in the memory, they generate the impulse response. Whatever the discrete input sequence and the from the memory generation, there is a impulse response, and after that, the output of this encoder will give encoded output in the form of m of t into h of t. At this output, we get a convolutional code. Okay, remember here one thing as convolutional code gives memory. Okay, and both the codes, the block codes and the convolution code, both the codes are linear codes. Okay, both the codes are linear codes. That is regarding the convolutional codes. Okay, so today what we have discussed today, as we are having the classification of the error correcting codes. Classification of the error correcting codes. In the classification on the basis of the parameter, we are having two types, which are the two types, linear codes and the non-linear codes. When we say that the code word is a linear code, as the sum of algebraic sum of the two valid code words will generate a new code word that should be a valid, then and then only we say that that code is a linear code. Again, the second property is that whatever the difference in between the two valid code words will generate the new code word, valid code word. Next, third property is that regarding the Hamming distance. The minimum Hamming distance between the two valid code words is equal to the minimum weight of the two valid code words. And the fourth property regarding the linear code word. Okay, these are the different properties of the linear code word. Now, what will happen in the non-linear code word? As there is a no any new code word generation, that should be a valid code word after the summation and the differentiation between the two valid code words. Okay, that is the non-linear code word. After that, we have seen the two types of the classification of the error correcting technique. As we are having on the basis of the functioning, we are having the first type block code and the second type convolutional code. In the block code, what we say that block code generates by using the k message bit which is given to the channel encoder, and the channel encoder which added a new block of n minus k parity bits, and these parity bits are nothing but a redundant bits. There is no information of the message in the parity bit or the redundant bit, and that's why it is called as the block code. Okay, in the block code there is no any need of the memory. Okay, then we have discussed about the convolutional code. In the convolutional code, we are having an encoder with impulse response h of t, and whatever the given message m of t, that should be in the discrete input sequence, and whatever the input sequence coming towards the encoder, there is a need of memory in the convolutional code, and in the memory there is a generation of the impulse response, and at the output of the this encoder we get encoded output in the form of m of t into h of t. There is a need of memory of the in the convolutional code, and both the codes, convolutional code and the convolutional code and the block code, both the codes are the linear codes. Okay, so these are the classification of the error correcting codes. So today we will stop here.